Welcome to part 5 of the Enemy NPC tutorial series. Today we will be introducing pathfinding to our enemy. This has been a pretty requested feature, so that's what we're going to do today. Before this tutorial, the enemy NPC would just target you and go directly for you. So if there was a wall in between you, it would get stuck on the wall. But by the end of this tutorial, you'll have an enemy NPC that learns to go around walls and can attack you from anywhere as long as it can get to it. And it will find you and it will kill you. So you guys asked for this, so I hope you guys enjoy. One disclaimer, after making this tutorial, stop hitting me. I realized that I was working on the part 3 model rather than the part 4 model from the last tutorial. The changes should be the same and it shouldn't affect how the enemy works. So if you're working from the part 4, that's fine. If you're working from part 3, that also works. So just wanted to add that disclaimer before we get started. And he's still attacking me. I gotta run. So I opened the new place file and I'm going to get the enemy NPC from part 3 that's in my models. You can also get this for your game as well. You can just look at the link in the description for the model link. I'll also be linking the finished model for this part as well in the description. So let's see what we have from part 3. If we add it to the game and start playing, our NPC has animations. If you get too close, it starts chasing. If you get even closer, it will start attacking. And you can see my health going down. And if you get too far away, it will stop chasing. But it's pretty stupid. Let's look at the issue here. So a lot of people brought this up and asked a question: if there was a wall between you and NPC, would it go around? And because of the simple nature, I'll make this transparent for you. Because of the simple nature of the chase, how it chases a player, it just goes for a straight line. So if there's something in between it, it's just going to, run into the wall. So the solution to this, and a lot of you know this, is pathfinding. Roblox has a pathfinding service that you can make it so that it would know to go around the wall in order to get to me. So I'm going to go into the dummy that we have. I called it dummy. And inside the humanoid, we have the script we've been working with the past tutorials called Enemy Controller. It's starting to get pretty large because 76 lines isn't too bad, but there's definitely a lot of lines to this. Let's minimize some of those functions that we don't need to know what's inside them. And we just have a lot of variables at the top of the script right now, which is fine. So what we want to do is we want to go to the top here, and above run service, below run service, I'm going to add the pathfinding service. So I'm just going to do pathfinding service, and it's equal to game get service pathfinding service. Apparently there's no pathfinding is one word, so I'll just follow what they have for capitalization. So this is a service we will be using to calculate all the pathfinding. We don't have to make any algorithms ourselves. We just got to use this service. Though the service can be quite confusing, and that's why this tutorial exists and why people wanted videos on this. So let's learn how to use pathfinding service. So in the not the FindNearestPlayer, because that just returns the player that's closest to the NPC. What we would need to know is, or what we would need to edit is this heartbeat function, and that's where our the chase, how the logic for how the enemy NPC chases the player, that's where it's located from our past tutorials. Because we have the nearest player, distance, and direction, and we just kind of have the NPC go in that direction if the distance is short enough. Well, we're going to have to change this a bit because we don't really need the direction. We just need the position now. So what we could do, we need that position first of all. So we don't have that with this function. We might actually have to go edit FindNearestPlayer to get it. But we do have the player at least. We have the distance. So let's actually go into FindNearestPlayer. And where it returns things, we got nearest player, distance, direction. We should also have a new variable called position. So I'm going to add a local variable at the top of our function called position. This is the position of the enemy NPC, and this is the position of the player that is found. So all we got to do is down here put position equals this and this. So now, and then we need to return the position as well. So now this function returns a fourth value, which is the position of the player that is closest to the enemy NPC. So I'm actually going to delete all of this and we'll just rework the logic a bit. We'll be doing some of the same things, but it's just kind of nice to start from scratch with this heartbeat function. So we need to add that variable that we are returning to, and we need to capture it. So I'm just going to put this here. Now this function returns 4 values: the nearest player, the distance of the player, the direction of the player, and the position of that player. If nearest player, then, so this is if there's a player and distance is less than target distance, because target distance, where is that up here? Target distance is the distance that you must be within in order for the NPC to start chasing you. You could call it the chase distance. So this is just saying if there's a player that's loaded in the game and the distance to that player is less than the target distance, then we start chasing. So rather than just taking the direction and moving that direction, we gotta do a function from PathfindingService. And let's look at some of the functions it has. We have create path, and that's going to be probably the most important one. Or find path async. Finds a path between the two provided points. And that's what we're going to be using. So let's do that. Find path async. And we give it a start position and the end position where we want it to end up. So the start is just where our enemy NPC is. And that would be root. So root dot position. And then the finish would be where our nearest player is, which is position from this variable here. And this returns a path. So for some reason, this function says it returns an instance. So if we were to index path and put a period, it only gives us like properties and functions of a typical instance, the base class of Roblox objects. It returns a path, which has its own special properties and functions, but it doesn't give you that right away. I think it's just a little bug that they didn't see, that find path async is supposed to return a path and not just a basic instance. So to tell Roblox that this variable is a path object rather than just an instance, just when you're declaring the variable name, put a colon and put path like this. Some people might remove the space or do this. I like having a space between the colon and the type, but that just tells Roblox that this variable name here is a path object. And you can do that with any type of Roblox object. Like I could say it's a player object instead, but this is a path, so we'll keep it at path. And now if we index path, we should have some path properties like status. So what we got to do is check to see if path.status equals enum.pathStatus.success. So if there was a path that could be created, we then can run the code inside here in this if statement. So if there's no path to be made, like let's say I'm surrounded by a wall, like on all sides, and there's no way for the enemy NPC to get to me, it wouldn't have the success. It would say no path. So we're just looking for when it succeeds at finding a path. And then if it does, it will start chasing. To do that, path has what's called get waypoints is a function. And waypoints are kind of what you would call the in-between points that the enemy NPC will have to take to get to you. So let's say I want to make another dummy just to specify what I'm talking about here. So let's say this dummy over here is trying to get to this dummy on this side. The waypoints might be, waypoint 1 might be here, so the enemy NPC would go over here first. Then the next waypoint would be down here, so then it would have to travel down to this point, and then the final waypoint would be the end position, and so it would start going there. So it's the in-between positions that the enemy NPC must take to get to its final destination. And there's going to be multiple of them. So we gotta loop through them. Unfortunately, PathfindingService doesn't automatically just make the enemy NPC move. We gotta do it ourselves, and we gotta loop through these waypoints and make the enemy NPC move to these waypoints positions. So let's get the waypoints. Let's create a variable called waypoints, and it's just path get waypoints. And now we're going to loop through these waypoints. So for waypoint in iPairs waypoints do. So now we're looping through the waypoints. And I think the waypoint should know it's a waypoint. Let's see. Nope, it does not. So this variable here is a waypoint. So let's do the colon again and tell it that this variable is a path waypoint. So now we should get, the properties of a path waypoint, which is position and label. We don't really need label, I don't think. I think the more important things is action and position. For right now, let's just start simple and work with position here. So this is the position of where. Let's oops, that's not how you spell waypoint. There we go. I'm just going to create a variable called waypoint position, and it's going to be equal to waypoint.position. So that's the in-between point that it needs to go to first. And all we will do is take our enemy NPC humanoid. I'm going to do move to waypoint position. And then we must wait for the humanoid to get there. So humanoid, move to finished, wait. So now we'll have the humanoid move to that position, wait, and then it will go to the next waypoint and do the same thing. Because let's just see what happens right now if we were to run this code. It's always good to test before adding complicated logic. Well, that's acting really weird, isn't it? There's also an error. Let's look at that error real quick. I just probably... Oh, yeah, oh, yeah. Let's first of all delete... So I updated the wrong dummies script. I'm going to go back to only having one again. And let's test this again. Let's look at what he does. If I get close enough, does he just go straight for the wall? No, he goes
He actually goes around. So this already works quite well. He is being really weird in the sense that we don't have the animations working anymore because apparently that was in the code before, and he doesn't stop at the stop distance. That's easily fixable, I think. All you gotta do is have a check here that says and distance is greater than stop distance, and then do an else if else, or else if distance is greater than, no, is less than or equal to stop distance, then humanoid move vector 3.0, which will make the humanoid stop moving. So basically we're just saying if the distance is, if we're in the stop distance, which is like 3 studs, so it's not too far away, we will just stop moving, so we won't run into the player, the enemy NPC. Oh no. Attempt to compare nil. Whoops. We need another check. We also want it to stop moving if there is no player at all. So let's put that in, put parentheses around it, and then do an or not nearest player. And let's try that. Let's see if it stops at the stop distance. No, but it's a little bit better. It's probably the move to, actually. I think move to overrides move. This might not work to stop it. Not sure. I mean, what if you did move to and then just did where it's at? And that would be root position. I don't know if this will work. Let's test it. Always good to experiment. Yeah, okay, so that fixes the stop distance problem. And finally, let's add those animations back in. This is running when it's moving, so what we can do is call that walking animation right here. So walking track play, and then once it stops, we will try and think of where we would put this. Oh, we would probably put it right here. Stop. Let's see if that works. Might not. Oh yeah, look at that. That's the problem we had at first when we created the animations. It's just that it keeps on playing it, and when you call play, it starts it from the beginning again. So all we got to do is check to see if walking track is playing, then, but we want it to only do it if it's not playing. So if not walking track is playing, play it. There we go. And then finally, we need to re-add the damage logic, which would be done. Let's just add it to the bottom here. If nearest player and distance is less than or equal to attack distance. So attack distance is a distance required for the enemy NPC to be at that distance or closer to attack a player. So now we're checking to see if there's a player and it's in that attack distance range. And if it is, we need to also attack. So we also need that logic we had before that checks to see how long it's been since the last attack, which is just a tick. So and tick minus last attack is greater than or equal to attack weight. So that makes sure that there's been, if attack weight is 1, this makes sure that's been 1 second since the last attack before it can attack again. Then we need to update the last attack variable to equal tick. And then we do the damage. So we have the nearest player. And we have it, there's a character. Local humanoid is equal to that. And then find first child of class humanoid. And then if humanoid, then humanoid.health humanoid take damage and the amount. So we have, I think we have a variable called damage up here. Or we did. Yeah. Yep. That's the amount of damage it does. We also need to make sure that the humanoid is alive. So, and humanoid.health is greater than 0. Take damage. And then we also want to start the attack animation, which is attack track. And now we should have an enemy NPC that walks around and does damage. And it really does. It's, you can see my health bar at the top left. The attack animation's working. Let's run away. Let's get away from it. Let's try to make it go through the wall again. So, I mean, it's not perfect, but it's much better than it was before. It doesn't just go through the wall. You can see that it's a little dumb, but there's some other extra parameters we could add to the pathfinding so that it jumps and stuff. I'm not sure if this one would right now, so let's test that theory out. Add a part here, anchor it, scale it. Let's do this. This will make sure we can see if it works or not. So let's say we have a little gap here. Enemy NPC is here. And our spawn point is going to be right here. Will our enemy NPC jump over this gap, or will he fall to his death? We also, yeah, that's another thing that you might want for your enemy NPC to be a little smarter. Okay, I made the gap too small, but he would have fallen to his death. I'll make it a little bit more clear. Let's make him a little closer. Stupid. Very dumb. So let's see if we can add that functionality. There is a setting real quick that I want to turn on. It's in, I believe, Studio settings. Okay, so it's called Show Navigation Mesh. Let's see if I can find that. Right here, if I turn this on, let's close this and look at this weird thing. So this actually shows us pathfinding capabilities. So if there is a link between two blocks like this, you see this arch thing, that means the pathfinding would be able to calculate how to jump over it. Let's say I moved it too far away and that link disappears. Then the pathfinding wouldn't be able to calculate a jump. It's just too far away. And then it does really bad if you make the jump like this. Oh, it actually does pretty good. Maybe they improved it, but it didn't used to do too well with height differences. But anyway, that means the jump capability is there, but we just, in our code, we don't have it capable of making or knowing when to jump or not.
But that's where, with the waypoints that we were working with, right here, a waypoint not only has a position property, but an action property. The action property is what we would find a jump. Like the pathfinding would tell us that we should jump. It would be in that action. So let's get the action. Oops. It's going to be equal to waypoint dot action, and then if enum dot waypoint action. Whoops, no. If waypoint action equals enum dot pathwaypoint action dot jump, then we want the humanoid to jump. So we just call humanoid and jump. I think all you have to do is dot jump equals true. Let's see if that works. I'm not sure. Well, it did try. It really did try. It tried its best. I believe the issue is that we're calculating the pathfinding every second. So when it's in the air, it oh no, I'm getting too close to it. It kind of second guesses itself, which is why you saw it kind of acting really weird. My recommendation would be to... Okay, so the issue, why it second guesses itself, is because we're creating a new path every like 60 times per second. And I don't know why, but when it's in the air, it tries to calculate again, rather than thinking it needs to continue going this direction. It's like, oh no, I gotta land on ground real quick, so it starts going the reverse direction. Sometimes it makes it fall. So all we gotta do is go into our run service, and we need to make it not call this if we're already in a waypoint, like we're moving to a place. We need to wait for this part of the code to finish before we call run service again on it, at least. So this is only the section of code that we need to not call every second. But what we can do is create a little variable called is moving, or is moving to target. It's going to be set to false, but once we get here, it'll be set to true. We need to make an if statement that says if not is moving to target, then and that should, oh, we also need for when it finishes is moving to target equals false. And that should finish it up. Let's see if it works. So it did a little, I think it did a little bit better. It's just that the jump is quite big. If we made the NPC a little bit faster, it would help. But it did look confident. It didn't try to go back on its path. So let's try it with a shorter jump. See, it can work now. And it works pretty well, actually, when the jump is small, at least. But if you want it to make a bigger jump, you just have to increase the speed and the jump height. And of course, it's going to mess up sometimes. One issue I've just realized is that if it gets out of range or it becomes a no path situation, it doesn't stop the walking animation. I wonder, it should see me now. So what happens if I run away? Yeah, so the walking animation never stops. Why is that? Oh no, let's go fix that. Let's look at the walking animation real quick and see where we stop it at. So we stop it if there is no nearest player
or if the distance is greater than or less than the stop distance. Well, that's an issue, because what if the distance is greater than the target distance? A little confusing line here. Basically, I'm going to add some more parentheses and put an or. Distance is greater than or equal to, or just greater than target distance. That, I believe, should fix that issue. Let's see. Let's run away from it now. Oh. It won't fall? Oh, that was weird. Anyway, there's some things we can work on for our next tutorial, but it does stop doing the walking animation now. It will do jumps to a certain degree. The one thing I'm noticing is that since we make it wait for the waypoints to finish, is that it doesn't update it quite enough. Like, it looks a little janky. So if I go around it, it will go basically past me like I'm still over there. It doesn't update every second. So, you know, the issue was only when the updating it every second. The issue was when it was in the air. So what if we didn't update it, or we updated it only if it's not in the air? So rather than taking this variable is moving the target and using that as a way to know if we should start moving to the waypoints or recalculating the waypoints again, let's just check to see if the humanoid's in the air. If not humanoid, dot floor material equals enum dot material dot air. So this code, oh whoops, I mean if it's not equal to. So this line will check to see if the enemy NPC is in the air or not, and if it's not in the air, then it will calculate the waypoints. If it's on the ground, it will calculate the waypoints. Let's see if he jumps now. Oh, he's a little jump happy, but he does do it. So, and this should fix, he's still a little bad at jumping, but he jumps. And this should fix, yeah, the problem of having the waypoints update too slow. So now he updates every second while he's on the ground, but when he's in the air, he will commit to the jump. All right, so that is the end of this tutorial. Now you have an enemy NPC that isn't thwarted by a wall. Before I go, I just wanted to let you guys know that I recently uploaded a game onto Roblox called Good Night Sleep Fright. It's a solo horror survival game. It's really short, about 4 minutes. If you guys want to check it out, I would love to hear feedback from you guys on it. It will be in the description of the video, and I also uploaded a trailer on to this YouTube channel for it, so you guys can check that out as well. Thank you guys for watching. I really appreciate it, and let me know any ideas you guys have for future tutorials, and maybe even future tutorials on this series as well. So, see you guys later. Peace.